All right, so to analyze or to insert the data to begin the first analysis step, what we need to do is we need to go into this spreadsheet here where the data is. We have our calculation sheet. We're going to be putting data from our acquired data that the students have acquired into certain spots in the calculation sheet. To do this, first of all, each of these are sections separated by these orange lines here, are sections where the data is going to be accumulated. So the first thing I'm going to do then is highlight the columns here all the way past the value like that, and I'm going to copy and then paste to create a new space for data to be pasted into. All right. Then I'm going to go to a tab of data. This is Hemo34PH5. I can copy that, the name of that sheet, and then go into my calc sheet where I'm going to paste that. That's going to go right up here. Alright, Hemo34PH5. And then I go back to the Hemo34PH5, and I'm going to create, highlighting those columns, inserting a scatter plot like that. I'm going to identify the slope of this line. Now I can generally see what the slope is. We have some noise in this data, but I'm going to choose a section that kind of gives me what I think will represent the best slope for this line. And what I'm seeing here is probably point number 43, 44 here, all the way to 60, 68, 43 to 68. So I go and highlight that range based on the time, 43 to 68, about there, copy it, and then I go back into my calc sheet here, and that was the first run. The one that's furthest to the left on these data sheets is the first run, and that's the lowest concentration. So I come down here into my calc sheet here where I'm going to paste this data that I collected, and I paste it to the lowest concentration. These values right here in this column right now are the concentrations of hydrogen peroxide that the runs were run at. Concentrations vary from run 1 to run 6, having increasing concentrations. This is the lowest concentration, second lowest, right? This is the highest, or the 6th run. So I paste that slope, for those data points that represent that slope well, right here. Paste that right there. I double click on this, and then I adjust the boxes here by grabbing the corners so that it highlights just my data points and nothing extra, and now it generates the slope of that line for me there, and that number is also copied over in this space here for the rate, the slope at which the hydrogen peroxide is disappearing. It's converted to a molar slope as well, and it's plotted versus the concentration of the hydrogen peroxide that was used. So I've got 1 point down there. I have to go get it again. Again, I'm looking for the Mayo 34 pH5. So I go back here. I want to look at this second one here. I can highlight this again and insert another graph. Another shortcut, though, I can just take this graph that I already have and just pull the Y data over to the right like that. And the reason I can do that is because even though the times aren't exactly right, they're pretty close, and in often cases they are essentially the same. And it doesn't really matter too much whether they are or not, because I'm not going to be taking the time from this point. I'm just using that to kind of get a visualization. So here I'm looking at this graph here, and it looks like from point about this looks like there's about maybe 0.6 seconds up to about 38 seconds. Probably give me a good representation of the slope there. Alright, so I'm going to highlight 6 to 38. Now, Notice how in this curve here we have a slope here, but then it slowly seems to be kind of leveling off a little bit. It's hard to say. It's not that much of a difference between those slopes, but if there is a slight difference, you want to take the slope that's closer towards the beginning of the run, because as the run proceeds, the temperature will change and adjust towards room temperature, and so the slope will change as well. Okay, so I want to, if I can find a good slope, I'm going to take it from the earliest spot. I've highlighted this region here. I'm going to right click here and I'm going to copy this. Alright, and now this is my second run. Oh no, I've got it on the third run. Did I mess that up? Let's double check here. Yeah, I chose the wrong data. I need to go for my second run here. Let's see, am I looking at, yeah, so I'm looking at this second run here. So I said 6 to 39, so that's going to be this data right here. Control C, copying it. Now I'm going to go and paste it into this calc sheet here. Here's where I pasted the data for the first run. Here's where I'm going to paste the data for the second run. I'm going to double click here, make sure that the data that I've highlighted is only the data that I've highlighted is being taken into account to make that slope, to get that slope there. Alright, so that gives me my second point right here. Alright, this graph here was copy and pasted when I pasted it, but I can click on it and I can see that it's not actually this data. So I do want to have this chart there so I can visualize how the data is looking. So I'm going to create a new one here. I'm going to insert this scatter plot here and of these points. This one here was for some previous data over to the left there. But now this one is the one that I've just collected. So I got 2 points, those 2 points I put in, and we have our 0, 0 point, no activity, all right, at no hydrogen peroxide. So we got 2 good points there. I'm going to go back and get the next one. Again, 34.5. Heme 34. Same thing here. I'm going to pull this over here to this y-axis. Looks like my values at about, this would be maybe 5 up to 40 or 38 are going to give me a good representation of the slope. So I highlight and copy that data, go to the calc sheet. This is my third set now. All right, my first and my second there. This one's going to go here. This value here is just perfect, so that's great. I got a new slope there, and there's my third point. Excellent. I'm going to go back again and get my fourth point. Heme 34.05 or 34 pH5. That's this one here. Click on this, pull this over like that. This data here looks a little bit rough in the beginning there, so maybe it looks like about 18 up to about 35. Or 18 to about, not 35, but 18 to about 58, probably. So right about there. There we go. Okay? I'm going to go paste this into the calc sheet here. That one was a little bit too much. See how it overlapped there? So that one I'm going to undo, and I'm going to go get the data again, but this time I'm going to just, well, here, actually what I can do is I can paste it right here, and then remove these last 4 points. And then I can just copy it there, paste it there. Good. Perfect. I could adjust that one more data point down, because I do have it. Whoops. There we go, and there we go. Excellent. And I can double check up here. Now that one doesn't look like it had, isn't following the trend well. Doesn't mean it's wrong, but it looks like the slope should be up higher. So I can double check and make sure that one, which was 34, heme 34 pH5, trying to see if there's a better representation of the slope, a space to take a better representation of the slope. It might be better between 60 and 100, even though it's a little bit noisy. I could try that. So I could try going from 60 to maybe 93, for example. Go back in to the calc sheet here, and this time I'm going to paste that there. Get rid of this extra point here.
That changes between.
So that didn't improve things too much. So at that point, we might want to go back and do it again. Will depend on how these other 2 points look when we're done plotting them. This was just temporary. We can get rid of that. Okay, so we continue to do that until all these 6 points, 1, 2, 3, 4, 5, 6, are somewhere along this curve here. Okay, good stuff. Oh, one more thing. This is hemoglobin. This is a reaction of hemoglobin at 34 degrees Celsius, pH 5. This value here, which is the Vmax, I'll show you how to put that in later. The kcat value here, it takes the Vmax and divides it by one of these values. And depending on what this value is here, we double click on this. If what this catalyst was. If this is hemoglobin, we want to make sure that that's highlighted, which like it is. If it was myoglobin, we would double click here and we would drag this down to myoglobin. Okay, so the different concentrations of the catalysts are different. But after you collect all this data, you can go in step 2 of the analysis. You're going to get the Vmax, put it in here, and if this is adjusted appropriately, if it's heme, we want the red box to be here. If this says myo, we want the red box to be here. Then the kcat will be generated, and the natural log of the kcat will be generated as well. Okay, good stuff.